Hello everyone. So today we are going to study a very interesting topic, or you can say that new topic is electrical capacitance. Electrical capacitance. Capacitance. So in earlier session we have discussed that electric potential energy, but today we are going to discuss electrical capacitance. First of all, we will concentrate over the word is capacitance. Suppose that I have taken a bag. In that bag, a luggage bag, I am putting some amount of luggage, and that luggage here I am assuming as a charge. If I fill this bag completely with the charge, what will happen? What will happen? It will be completely filled. And again I am giving the charge to it. What will happen? That charge will be split out. That charge will be scattered. These charge will not go to the bag, because we know that the capacity of the bag, that it can hold a certain amount of charge. So what is going on? Due to the giving the charge to this bag, the potential of this bag will increase. The potential of this bag will be increased, as we know that if we are giving a charge to any conductor or the surface, the potential will be increased. We know that V is equal to K Q upon R is there. So the potential is increasing, or the charge is giving at the certain limit, the bag will be fulfilled. Whenever the bag is fulfilled, then it will not accept the more charge, and we are trying to give it the charge. The charge will not be accepted by the bag. It will be split out into the environment. So whenever they are going to the environment, it is a totally waste at all. So what we got to know from this example, that bag have the certain limit. That limit is called the capacity of that bag. And similarly with our conductor or the insulator also, that every conductor, you can say that insulator have the specific property to sustain a charge over its surface. Okay, so that is what called the capacity of that conductor or the insulator. In case of insulator, it have the certain amount of shape and size. If we increase the shape and size of this bag, as well as we can put the more charge inside it. So we can say that we can increase the capacity of the bag. If we take the larger amount of bag, we can hold the larger amount of charge. Similarly with our insulator or the dielectric also. If we take this larger shape, the amount of charge over that shape, over that surface is larger one compared to this one. So in case of seeing these examples, we are easily able to understand that the capacity of every surface or capacity of bag is fixed. If the bag is the larger size, it can hold the larger amount of charge. We can say that it have the higher capacity. And similarly with if the surface is the larger one, it can sustain or it can hold the larger amount of charge. So the smaller surface have the smaller amount of charge. The capacity of a smaller surface is lesser than the capacity of larger one. So this is what we are thinking about the capacitance. If we talk about the electric capacitance in terms of charge, what will happen to it? If charge is going over an surface, what will happen? The potential will increase. So the capacitance definition may be defined as the amount of potential increased due to the giving charge. The amount of potential increased due to the giving charge. It is also defined as this. So now we will concentrate over the definition. What will be the definition of capacitance? What will be the definition of capacitance? Generally, we can understand that the maximum limit of any surface that can acquire a maximum amount of charge is called the capacity, or this you can say the capacitance of that surface. But see differently how you will define the capacitance. So capacitance relation gives C is equal to Q upon V, the amount of charge given to increase the potential of that surface is called the capacitance. So what is the capacitance? Capacitance in terms of this one, the amount of charge, you can say that the ratio of charge which will increase the potential due to supplied, or you can say that supplied charge to it. Okay, so this one. Another definition can be defined as that if we take the, you can say that V is equal to 1, V is equal to 1 volt, we can say that amount of charge given to increase the potential 1 volt is called the capacitance of the conductor or the insulator. So what we can say that if we given amount of charge, in that case C is equal to directly proportional to Q, ऐसे कह सकते हैं, C is equal to U भी कह सकते हैं. So what is happening here, that we have given a 1 volt, or you can say that 1. So whenever given a 1 volt potential difference, or you can say that 1 volt potential difference is increased, the particular amount of charge is called the capacitance of that surface. So that is the another definition. What is the SI unit of this one? We know that the coulomb is the unit of charge and the volt is the unit of this one. So we can easily say that 1 coulomb per volt is the unit of capacitance, because it is given by the Michael Faraday, and that the another unit is generally we use farad. The symbol is capital F. But what will happen, that farad is a very anomalous, you can say that very large unit of this capacitance. Generally in our day-to-day life we use 1 microfarad, which is equal to the 1 into 10 to the power minus 6 farad, and sometimes we also use the picofarad, which is equal to the 1 into 10 to the power minus 12 farad. So these are our general use unit, because the farad is a very large one, so it can't be, you can say that, easily calculated. Just upcoming example will give the idea that farad is how much large it is. So we have the two SI unit, one is this one and second is this one. These are the two SI unit, and here what is going on here, these are the general use unit, microfarad and picofarad, which have the relation with this one also. So these are the unit and these are the definition and example. Now see that example, if you can say that if we take the example, if the charge is 1 microfarad, or you can say that picofarad, yeah, suppose that, take the example, we want to achieve 1 coulomb, or we want to achieve 1 farad capacitance of a surface. So that surface is how much large? That surface is how much large? We will try to find out it with the help of this example is going to be here also. Now charge, or you can say that capacitance of a spherical surface, that will definitely give you idea about that the formula which is about to come, and as well as that how you will achieve the 1 microfarad. Will this example we will see that. Assume a spherical surface, it can be a shell, it can be a sphere, it can be a hollow sphere. So having the radius r, the amount of charge stored over that surface, which will be considered as a capacitance. So that is what, and the electric field will be outside. Electric field of this charge will be outside. Now we will calculate the capacitance of this spherical cell, or you can say that hollow sphere or solid sphere. We will see it. We know that capacitance is depend on V. Capacitance is depend on V. So what is the formula for electric potential? We have discussed in previous session, previous video, that 1 upon 4 pi epsilon naught is basically the total amount of charge present over that surface is divided by the distance. Distance is what? R. So distance from the center is what? R. So potential is at the distance at the surface is this one, the total amount of charge divided by this one. Or according to the definition, we have the formula Q upon V. If we put the value of Q here, we will find out that very interesting relation which will give the formula for finding the capacitance for a spherical or a shell or thin spherical shell like this. So that will be our capacitance for this assumed sphere here. That may be hollow, solid and thin. So the formula will remain same for all cases. But we will see that we are taking the example of 1 microfarad here. If we put that C is equal to 1 farad into this formula, what will happen? C is equal to 4 pi epsilon naught R. So 1 here 4 pi epsilon naught R, then R is equal to 1 upon 4 pi epsilon naught, then R is equal to, what will happen? 9 into 10 to the power 9 meter. So you can see that how much large radius sphere we needed to store that, particularly you can say that 1 farad. So 1 farad is enormously a large unit, or you can say that farad is a large unit which gives the capacitance or shows the capacitance, and we need, for store the 1 farad capacitance, we need that this much amount of large radius surface of spherical cell. This 10 to the power is much more than the radius of earth also. So we can't make such a surface that can store a 1 farad as the sphere. So that is impractical at all. So that's why we use the practical units is generally microfarad and the picofarad for calculating or for the measuring the capacitance. In other example, if we want to take that, how much capacitance will be offered by if the radius of a sphere is 1 meter. So we can easily calculate with this formula also that C is equal to 4 pi epsilon naught, and we will put in place of our this one, we will find out what is going to be happen here. So 4 pi epsilon naught, or we know that the value of 4 pi epsilon naught is something what 1 upon 9 into 10 to the power, what will happen? You know that the value of 1 upon 4 pi epsilon naught is this one, okay, and then here what will happen? It is gone to the up denominator to numerator. The value will be in the terms of negative as well as. So that is why we are doing here. So whatever value will become after that, it will becomes as a farad. So that is very smaller one. You are seeing that minus 9 power, which is very smaller one, which is giving a very smaller one unit, or you can say that 1.11 something like this. Very smaller unit is this one, or you can say the very smaller amount of charge present over the 1 meter radius sphere over the surface. So that is the capacitance offered by the, you can say that two diameter of radius, 2 diameter having the spherical cell or thin spherical cell or solid spherical cells will be offer only this much very less amount of capacitance into the 10 to the power 1.1 into 10 to the power minus 9 farad. So these are the examples. Or if we concentrate over this one, if what we have now noticed that our capacitance is totally depending over the shape, size. What factors it is depending? Shape, size, and as well as the dielectric. If we calculate the capacitance in terms of this one, the formula for capacitor is 4 pi epsilon naught sphere. It can be, we can also use here that K into R. So K is what? K is what? Dielectric constant. The environment around this sphere will affect definitely the capacitance. So the environment matters, the radius matters, or you can say that shape and size. So shape, size and environment affect the capacitance of a sphere, not the other things. You will see that in that formula there is no charge at all. There is Q is absent here. So only the things affect the environmental things and the radius, or you can say that shape and size and environment will affect the capacitance of a spherical shape or a spherical body, and it is thin spherical, solid spherical, hollow spherical. So it will be depend on a shape, size. Capacitance will depend on a shape, size and environment, and it is not going to be depend on a charge. And one more thing is that the formula will work for the any type of spherical, thin, solid, or you can say that hollow sphere. So that is what we are discussing. And another thing we can concentrate over, that the capacitance is become greater if the environment around this conductor is insulating type, or you can say that dielectric type. So if we fill that environment around this, the dielectric, the capacitance is increasing k times. So that is also the method of increasing the capacitance, and these are the basically you can say that shape, size and all related to the capacitance. Capacitance is basically the amount of charge stored in a particular surface, particular body. So here we are assuming that the spherical cell will be work as it is. So that is what we have today. Some two numericals also we have concentrated as example, and some are the definitive work, and little bit of small deduce or expression of the formula for capacitance for a spherical shape only. Thank you very much for joining me.